Hey everybody, how's it going? I don't know if you can hear my music. Hear my mic. I'll turn it down a little bit for me. I'm playing it out loud because I'm too sleepy to wear headphones. Snurk. Me, 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 me. That's me right now. Oh, I have my welding up. Oh, this is my welding project. It's basically a box, but I put some stuff in it, and you have to weld this with a little welding thing. This is the welding thing. Anyway, this is the same box we made in class, but I put two things in the middle. Hopefully he's not like, what the fuck? But if I got put in that box, I'd be so happy. Look, I'd like be over here, and I'd be like a little catboy. I'd like snuggle up. I'd like do a little loaf. I'd be like, wow, this box is so great. This box, hopefully I can take this box home when we make it. But somehow we're gonna have 3 people making this box. Oh, I forgot an integral detail. One of the people in my group wanted to plasma cut a heart out and put it on the side. I kind of don't want to do that, so I didn't put it on this thing. But yeah, what is that? What are any of these? What do I have? Oh. Anyway. We're gonna be sleepy because I have to do, this is not due till Wednesday, but I have Hell Week stuff for dance, and I do not want to be Hell Weeking while I have physics to do, because then I can't stream it. And what I need to stream is what I do. I'm a cat boy. I just stream. Okay. Let's see. You know what I should do? Maybe I can just do this right now. Let me like see if I can crop, like get up a source of like the problem. Because I normally just read it out, but I feel like that's like kind of like silly. Like, let me crop this to like, what problem are we doing? We're doing problem 5. Wait, let me like zoom in. That's as much as I can zoom in. Oh, where is it? There we go. Now you guys can see it too. It's not just me. Yeah, I'll put it right above you, chat. Put it right up in the top here. Like, move this out. You can tell this is scuffed because I'm sleepy. I know not soon because college core. We should do another Jackbox stream. We should do another Jackbox. I actually have a break next week. I want to do art though, because I really want to re-rig Damie's mouth. I mean, my mouth. I mean, yeah, I'm not a rig. Too sleepy. And I also want to kind of redo my stream layout. I'm thinking, can I explain parametric equations? Yeah, I can totally explain parametric equations. Where do I start? Okay, so parametric equations are basically just like any other equation. Except instead of having like a function that's directly saying like y is a function of x, we're gonna... Does t mean different time zone? So instead of having y as a function of x directly, we want another middleman variable to go between the two. So if we're going from... It's like both of these are dependent on this other variable. So that's kind of the basic concept of parametric equations, which means that you can have something like x equals 2t, and then y equals like maybe 4t squared plus 3, right? So we know that these are dependent on time in their own ways, and because they're both dependent on time, they are actually both dependent on each other, and you can eliminate t out of these equations by like solving for t and then setting them equal to each other to get the relationship between x and y. But in physics, we use parametrics because we want stuff that's dependent on time. Like, let's say, I don't know, like maybe your acceleration is dependent on time, or maybe your velocity is, or whatever. Does that make sense? When we do polar coordinates are actually also parametrics, if you think about it. Because when you have like you have like x equals r cos theta and y equals r sine theta, your theta is your parameter that's connecting the two, kind of like t. Okay, what's this question? I forgot. Already forgotten. Let's say, okay, find the total kinetic energy increase. So we have to do KE initial equals... Oh dear lord, I forgot about this. 1/2 mv squared equals 1/2 7 times 10 to the -27th times 0. Never mind, it's 0 kinetic energy. We don't have to do that. Okay. Can I explain spherical coordinates? I have not done spherical coordinates yet, so no, I can't explain that. I'm sorry. How many cars can I eat? I can eat 0 cars. 1/2 times 5. Wait, can I do this with momentum? The delta V's. I'll do it this way. 5 times 10 to the -27th times 6 times 10 to the 6th squared. Can I explain double integral? Also haven't done double integrals. Although I imagine it's just like, are you just integrating twice? Nah, I have not done that yet. Like, for context, what literally I learned today was about the equation of a plane, which is like the normal times. It's not that simple. I don't know. I haven't learned it. I'm just guessing. I wish it was like that before and you're disappointed. Yeah. That's like physics. That's like kind of physics core. Or kind of math core. Times 10 to the 6th squared, and then KEC equals, what did we say it equals? 3.6 times 10 to the... 3.6 times 10 to the -27. You have to learn how to set it up. Yeah, wait a second. Wait, sorry, wait, I got 12.1? Did I check this and get this right? There is no... These guys are moving at magnitudes of orders 10 to the 6th. There is no way this is 12.1. There is no way this is 12.1. 1 second. Wait a second. Oh. Well, kind of. Did I just like... What the heck did I do? Okay. Okay. Did I just forget the 10 to the 6th? Oh, I forgot the 10 to the 6th. I forgot 10 to the 6th. Oopsies. How does angular momentum work? I'm gonna be real, I have not done angular momentum in like 2 years. But... I think, if I remember correctly, the main thing about angular momentum is just like... is just knowing when momentum is positive and negative, right? Which is just the right hand rule. So like if it's going counterclockwise, then the velocity goes up, and if it's going clockwise, then the velocity vector omega goes down. And so you just have to like know this for... I do not remember. Gonna be real. I know I am not giving a lot of answers, but I would rather not like bullshit you. I don't want to bullshit you. Wait, what? How did I get this? 8 point... Wait a second. 8 point... What about inertia? Well, okay, so inertia... I guess it depends on what you're doing with inertia. It's like if you're calculating the moment of inertia, that's like kind of... That's like hard. But I mean, the concept of inertia is just like... It's like momentum with extra steps. Again, I think that we're slightly off in... Like, my class has not done that yet. And I haven't done it for like 2 years. So I am not up to it. I'm definitely also not up to it. I'm not up to date with it, like, for calculus. What was I looking up? Oh, I was gonna look up calculator. I'm losing it a little. Okay. I had 8.4 divided by 3.6. How did I get... Who let me write down 8.89? That's not... Oh, did I add the cos theta in there? No, what the heck? Bro, what was I doing? Oh my god, it's 2.33. What is happening? 2.33, and the other one is 5.6 divided by 3.6 is 1.5. Where was I getting this? What was happening? Did I just... What? Times 10 to the 6th, times 10 to the 6th. So this is not right at all. What was I... Oh yeah, I was like trying to figure out how to store spring earth in my room. That's what I was... That's probably why I was really out of it. Times 10 to the 6th. Okay, so 3.22 or 2.33 times 10 to the 6 squared. Plus 1.55 times 10 to the 6 squared. Square root. 2.33 times 10. Oops. This plus 1.51 times 10 to the 6th. This the square root of... Okay, yeah. 2.7 times 10 to the 6th. That makes a lot more sense. 2.7 times 10 to the 6th. Or 2.8. Have I learned line integrals? I don't think I technically have. I have, like, my professor, like, mentioned it, but I literally don't trust him at all because he told us that, like, a matrix was a determinant, and that is not true. He has a tendency to, like, just gloss over, like, any sort of stuff that we possibly don't know instead of, like, actually telling us stuff. Which is just silly. Oh. Oh, what? Oh, there you go. I think this could be right. It's kind of how it's gonna go tonight. I think this could be right. I don't want to do this kinetic energy thing though, because like delta KE should equal 1/2 m delta V. So like, I think maybe he just wants us to say like, oh, the delta V's. But I kind of don't trust that. Let me look this up. Or like finding total kinetic energy increase in collision. Final kinetic energy. What? no, that's a different question. Wait a second, wait a second, wait a second, wait a second. This is actually a good point. It says, find the total kinetic energy increase in the process? Ha. There can't be a kinetic energy increase. Kinetic energy is not... If it's not increased? Does it mean like total kinetic energy increase for that particle? Yeah, but the total implies that it's everything. What? You can't make kinetic energy out of nothing. Do I just like kind of say fuck it we ball? I might say fuck it we ball and just do the increase for the particle. Because that's really weird. Like you can't increase kinetic energy of like in a collision. I'm just gonna say Ke or delta K equals 1/2 m delta V. Which in this case is delta V squared. 2.8 times 10 to the 6th meters per second. That was weird. I don't like that. I don't like this question. 0.5 times... The mass of this one is 3.6, I think? 3.6 times 10 to the negative 27th? I'm not lying about that. Yeah, it's 3.6. Times 2.8 times 6. Squared. Okay, it's only a little bit of increased kinetic energy. It's such a little guy. I'm just gonna say yeah. This'll do. It's like, not great, but it's not bad. Don't you have to learn angular momentum in this quarter as well? Yeah. We're gonna learn that like tomorrow, I think. We just did, he just is doing like the linear, not the linear, the angular motion, like constant alpha equations. We had our midterm like, because we have week 9 is, you haven't learned the the conversation. Do you mean like, what is it called? Conservation of energy. That is really strange. Have you talked about energy at all? If you've learned about energy without talking about conservation of energy, I would be like, what is up? That's strange. Okay. A wheel starts from rest and rotates with a constant angular acceleration. Okay. So V, well, what do we want to say? Omega 0 equals 0. Constant angular acceleration, so we have an alpha to reach an angular speed of 12, okay, 12 r per rad per second in 3 seconds, t equals 3. Find the magnitude of the angular acceleration of the wheel, okay, and the angle in radians through which it rotates in this time. Okay, so we're going to look for this, and we also want delta theta equals what? So we can use our handy dandy little things we always use. So we want alpha, and we've got a V final and a T. So, okay, so omega final equals omega initial plus AT, which is 12 rad per second equals 0 plus, sorry, alpha T. It's alpha times 3. So alpha equals 4 rad per second squared. Nice. And then our delta theta, we can use... we can use any number of things to find delta theta. We can do... let's do this one. Delta theta equals 1/2 of omega final plus omega initial times t, which will be 1/2 12 times 3 equals 18. 18 radians. I think. Is that it? Okay, stay winning. Let me see if I can check that real quick. We stay winning is what we do. Yep. It's like the slave virus got to me. Oh, it's only 7:20. I keep thinking it's like 9:20 for some reason. It's because it gets dark out so early now. How are you guys doing with the time change, with the darkness now? I hope you're doing well. Let me turn this off real quick for 1 second. This is actually waking me up more than I thought it would. I thought I was gonna be like so sleepy. I might need to sneeze. Fine. Okay, problem 7. Oops. Okay, what have we got? It's crazy to memorize all the different topics at once. Like, for me? Or just like in general? I think it's helpful for me to be doing some of this stuff at the same time because, like, like, we're talking about cross products in Calc 3. And it's like, oh, we use those in physics. And my physics teacher doesn't explain them, but we use them in physics, and it's cool that I can see that. I always had to speed learn a calculus topic in 1 day prior to the exam, and then can only apply the logic to solve them. You set yourself up for failure, man. Start studying earlier. I mean, you can't be having exams every day, right? Unless you are, which is like, what? Always try and stay on top of stuff. Determine the angular, okay. Angular position. So we want theta, omega, and alpha. At t equals 0. Oh, thank you for the follow. Wait a second. Sorcerer Juan 574. Sorry for the little boring little stream today. We're just doing some ballin', I don't know, rotational motion. I didn't know what we were gonna be doing, so I just said physics. Let's get an omega here. Let's get that. Let's pull out this little omega 4t. Oh, so simple, so serendipitous. Hi, Damie. Nice to find other math and physics person here in Twitch. Oh my gosh, yeah. Do you stream math and physics too? No way. This is like, I swear I do more physics than this. This is like, oh, it's just 5 radians. And then W is just 10 rad per second. And then this is just 4. It's always 4. I'm simply just a little cat boy who enjoys doing math and physics and things. I really do want to, like, get a better layout, though. My layout is, like, what do I need to do? T equals 3. I've been glad to be able to help out people more lately, though. No, I'm just a viewer that likes math and physics. I think I want to be a theoretical physicist or mathematician. That is dope as heck. I hope you do that. I am very much not a theoretical person, although I do enjoy theory sometimes. I kind of just had a bad relationship with it when I was learning most things, so I kind of shied away from it a little bit, but Okay, 5 plus 30 plus 18. What I really want to do is just like teach people stuff in a way that is I don't know, harmonious, serendipitous, if you will, beautiful. Ways that people can understand like complex math concepts in a very gentle and loving way, and instead of a we're just gonna do a bunch of proofs, but also proofs. 48 plus 5 is 53. Equals 10 plus 12. I can't wait to start like really doing lectures. I'd really like to do lectures. It was funny, my professor... I see, teaching others with kindness is really a blessing for students and you as well. I think so. Do I know group theory? That's a good question. Do I know that? Off the top of my head, I'm gonna say no. If you maybe give me a little bit more about what that is, it might spark my memory. Differentiate to find the angular velocity in a winding turbine is insane. It's not that bad. It's not that bad. You just take a little derivative. Give it a little hug and a kiss. I was gonna say, it was really funny because my professor today, he was like, oh, during COVID, I was having such a hard time like teaching lectures because I was just talking to myself in a room and lecturing, and I'm going insane. And I was like, I do that. The theory of turning actions into pure math. Oh, that sounds dope as fuck. I don't know that though. I really probably should put like, I'm not a math major. I'm a mechanical engineering major. So I do a lot of applied stuff. I'm just kind of vibing out. I took linear analysis like really early. So I know some stuff. It's not an axiom because paradoxes, that sounds like really awesome. I tried so hard to learn real analysis when I had a couple months off. I got like a textbook and everything, and it was just, whoa, it was going way over my head. I'm gonna note that down. I'm gonna write that down. Group theory. Group theory. Honestly, I am kind of sad because like the thing that I take up to at my university is linear analysis 2, but I don't have like, well, I can take other math courses, and I probably will take at least another one, but it's just kind of sad because I guess I don't really get to learn anything more than I already know for the most part, which is wild to think about because like in high school I did up to linear analysis, but not multivariable. So this upcoming quarter, not this one, I'm doing multivariable. Like jumping is its own thing, and circles and rolling on stuff. I just hate differentiation. Why do you hate differentiation? It's chillin'. I don't like integrals as much. Integrals are, dude, all my homies hate integrals. No, all my homies hate integration by parts. Is the reality of it. That's okay. Integration by parts can stay. You can differentiate in physics, but you still can't get the solution? I mean, sometimes you gotta plug stuff in. I don't know, I feel like the most derivatives I encounter in physics are way nicer than the ones that my math teacher used to give me. Okay, tub of water goes into its spin cycle, starting from rest. And group theory is fun. Do you have like a textbook on it? I will read that textbook if you have one. Or I guess I could find one. Starting from rest? I mean like more, do you have a favorite textbook on it? Rad per second. And gaining angular speed steadily at 8 seconds. So we've got an acceleration. T equals 8 seconds. At which time it is turning at 5 revolutions per second. 5, oh, revolutions per second. We'll do this then. rev per second. Text what level of text? What level? I'm like, I haven't taken multivariable yet. So I don't know what that, I don't know where that puts me. Again, not a math major. Not a math major. I'm not required to take any theoretical courses. At this point, wait. Oh. Okay, yeah. Level 12 high school? Yeah, I mean, I did, we're doing like some vector analysis stuff, roughly. Oh, actually, I lied. I've taken linear analysis and like, I took some linear analysis basically up to like, eigenvectors and root nullity theorem and all that kind of junk. And then I also took some differential, but like differential without multivariable, which is a weird thing, but we somehow tried to do that. To be honest, I don't know how to do pre-calculus problems. Okay, my little confession is that if you gave me a pre-calc problem, depending on how bad it was, I probably wouldn't be able to do it that well. But like, I would understand like what's going on mostly. Just use a paper and pencil and do stuff from scratch? I don't know what that's referring to. I mean, you can, yeah, do paper and pencil. Okay, so then we have a second velocity. A second part. I'll just put, we can put like 1. And then omega 2 is going to be 0 revs again. And this delta, this is T1, and T2 is going to be 12 seconds. The frequency sine wave can be somewhat crazy. Well, the thing you have to realize is that like period and frequency are inversely proportional. So once if you could think about it like this, then, and if you know like just conceptually that a period is like one time that this happens, it's like, it's not as bad. After that, I will give you a heavy book. Yes, but how can you remember to plot the inverse trig graph? The inverse trig graph? Have I ever had to graph? What? Have I ever had to... Wait a second. I mean, I definitely don't use it if I have had to graph it. I'm a bad math student. Oh, yeah, no, I don't do that. I mean, I guess the easiest thing I could say is just like... with Euler's method. You had to memorize all the trig graphs and trig identities? Well, I had to memorize the trig identities. I didn't have to memorize the graphs of any of the inverse functions. We just had to like know that they were the inverse functions. Okay, so we need the delta thetas for both of these. Delta theta equals what? We can do this by saying we don't have an acceleration, so let's just do delta theta equals 1/2 the final velocity 5 plus 0 times time equals 5 times 4, which is 20. So 20 revs per second. Or no, 20, just 20 revolutions. And then delta theta here is going to equal 1/2. And we start at, starts at 5. And then it goes to 0. Times 12. So that'll be 30 rev. Yeah, I don't really know why this is hard. I think this is pretty simple. There's no trig for the 5th dimension, and 6 and 7 we have 1. Wait, and there's no trig for the 5th dimension, and 6 and 7 we do have 1 for 8 and 27. After that we have 1 for 2000 to the 194th? Bro's quoting spells at me. I don't know what that means. I'm gonna take your word for it. Partial friction? Partial fraction decomposition? Partial fraction decomposition, my beloved. I love it. Like all you have to do is just factor it, right? Nope, that's not how you factor that. Wait. X minus 3, X minus 1. Oh, to the 149th factorial? Oh my god. And then you just say A over X minus 3 plus B over X minus 1. And then you have a little fun time and you do a little system of equations. Oh, it's so fun. Because it's so simple and I don't have to do anything for it. You still have to compute triple integrals? Well, I don't know how to do those, so it's fine. The only fancy integral I know of is this kind. With like the circle, but I think that's kind of stupid because we do that in parametrics and we don't draw a circle, so. Physics common, physics L. Actually, I think the most massive physics L, let's be real, the most massive physics L is saying that the norm of vectors is like this. Bro, the norm of vectors is like this. Anyone who, whenever I see this in physics, I get actually mad. I get actually so mad. I'm like, guys, please. Please don't write that. What if we need the absolute value of anything? What if we need the absolute value? Just use 2. Anyway. That's my little rant. Okay, problem 9. A rotating wheel requires... Okay, so 3 seconds to do 27 rev. Its angular speed at the end of the 3-second interval, so t equals 3 seconds. Finding the curvature in scalar form can be somewhat crazy. You're just quoting word. I think we've gotten to the point where our paths have diverged because I don't know about that. You must be doing multivariable stuff before I am. Because like in my like Calc 4 is multivariable stuff and Calc 3 is not. We just do some stuff about planes and lines and silly little vectors like, oh, there's a plane in here. And like, let's project if we have like a, oh, we have a plane like this and there's a line like this. Like, how do we like, you know, project the line onto, like, what's the distance between the line and the plane, you know, stuff like that. Sort of like that. I'm excited for Calc 4 though. I'm excited for multivariable, a little funny little multivariable. Its angular acceleration at the end of the 3-second interval is, I'm gonna assume it starts from rest. It's like, rad per second, F equals 98 rads per second. Okay, equals what? And we have, what we don't have is, we do have a delta theta. I mean, we do, oh, 37. I mean, if we didn't have a delta theta, we could just do VF minus V, oh, wait. Wait, it takes 3 seconds to go through, oh. The time is... Wait, I have a time. What? Oh, are they giving me... Wait, so it's telling me there's 37 revolutions happening, but I only need... Oh, maybe this is not here. Maybe we don't have this. Let me figure this out. So we definitely have a 3-second period. And we definitely have an omega final equals 98 rads per second. And it takes it 3 seconds to do 37 revolutions. Which means that for 3 seconds, we go through 37 revolutions would be 37 times 2 pi radians. So 323, no, 232, 0.5 rad equals delta theta. Then we have, we want to find this. And I don't think we have an initial. I think that's what we don't know. Yeah, so we have to use the delta theta equals VI. Nope, I lied. We don't have a VI. What can we use? I mean, I can find VF by doing delta theta equals 1/2 omega I plus omega F times 3. Oh, times T. We'll do that first. 1/2. So 2 times 2, 32.5. We want to say, what do we want to say? It's gonna be like WFT minus 98 times 3 over 3? Is that right, chat? I don't know. Maybe? I can check that in a sec. Maybe a little right. Maybe a little right moment. I have to get up at 8 a.m. No, I don't have to get up at 8 a.m. tomorrow. I have to be in lab by 8 a.m. tomorrow, so that'll be really funny, silly. I'm not particularly looking forward to it, but I can show you guys what I make if we end up making anything. I don't know what we're gonna do. I think we might pull apart welds that I made that were actually really nice. I don't know if they're gonna be strong though, but they looked pretty and I wish I could have kept them. Yeah, so we multiply T over... Well, no, I'd rather do like... The formulas in vector calculus is more intensive to memorize than pre-calc. Oh, like for... Yeah. There are a lot of new symbols to learn, yeah. Like the zeta function. I'm not familiar with that particular function, but I do know that like when you get to linear algebra, or linear analysis, or linear algebra, or whatever you want to call it, like that becomes... It becomes a lot of memorizing because it's a lot of vocabulary. Why am I blanking out on how to do this, bro? 1/2 T minus 1/2 T WF over to... I'm losing my mind. I'm losing my mind, chat. Can I just... We'll get there. Even the partial derivative with new symbols can be somewhat confusing. Yeah. Okay, there we go. Omega I equals 2 delta theta 2 times 232.5 over 2, no, over 3 minus 98. You have to take implicit differentiation for 3 variables. Yeah, I kind of remember that. Except mine was like minus 98, sorry. 57. Oh, that seems right. Equals 57 rad per second. Wait, did I do this right? It's easy if the z variable is in one side. Yeah. Yeah, it is a problem, but the problem is the z, yeah, mixed with all the other variables. I will say, we had to do the phi problems. You may or may not be familiar with this if you're like a math major or whatever. But like my differential equations class was all based off of very specific differential equations. So like we studied like the e to the x, like c e to the x stuff. We studied Bernoulli. We studied like really specific cases because we couldn't generalize it. But we did use like some linear algebra and stuff as well, a linear analysis. But like we did like the phi case where we had to like do the partial derivative and then like put it back into the other thing. And that was confusing. Or he always would give us like trig functions inside trig functions and stuff. And that was annoying. It was a little silly. So 98. So okay, sorry. Omega f equals omega I plus at t. So then omega f is 98 minus 57 over 3 equals... First, I think calc is as crazy as multivariable. Yeah, you know, I think that series and sequences can be taught really poorly. 13.6. I think that they can be taught really poorly because I experienced them being able to be taught really poorly. Because like the motivation of them, like I was so mad that I had to learn them because I was like, this does not matter. This doesn't matter. I still don't know how to do a Taylor series approximation. It's really funny because I also don't, but I know how to do a Taylor series. I can't approximate the error because like we were like, we're gonna just like memorize Lagrange. So like if we're just gonna memorize something, then like what's the point of doing it if you don't understand it and you're just memorizing it? Error bound is crazy. For real, error bound is crazy. Because you need to do like a bunch of stuff to you need to know like multivariable and like even past multivariable stuff to understand what they're doing with that. So why would they teach it in Calc 3 when you don't know any of that? That's my professor's logic. He was like, I'm just not going to teach you guys this. And so he taught us like about this other way to approximate Taylor series, which is like saying the Taylor polynomial of degree n centered at a of function f of x, like the error is equal to like the Taylor, you know, the sigma fn of a x minus a to the n over n factorial plus the integral from 0 to n, no, 0 to infinity, no, n to infinity of f to the n plus 1 of a x minus a to the n over n factorial. And by using this integral, we proved this basically by like doing the remainder theorem, where if you like divide this polynomial by itself or something dumb like that, I don't remember. I'll have to study this for the final though, so I'll like explain it better later. But you can use this integral, and then if you want to say like, oh, I need this integral to be like, I want the error to be less than like 0.001 or something, you just have to figure out how many terms you need to make this smaller than that. I think it might be 0 to n. I don't remember. So it's like, this is we want to approximate this integral because there's no point in trying to find this integral ever. It's just so that we can figure out how many terms we want to go out to, basically. Okay, this one's done. Okay, last one, and then we gotta circle around and finish others. It's confusing. It is confusing, and that's why I'm not gonna teach it today. I really want to do lectures so bad. I just don't have time to do lectures. Also, I'd just be stealing my professor's lectures. No, I want to make slides and stuff and have like a good lecture. You know how it is. I started doing, I have a VOD. I don't remember if it's up. Is it up? Wait, let me check. I do have a bunch. I've been saving all my VODs. I just haven't been posting them to YouTube. Whoa. Hello. Oh, I forgot. Where is this? Yeah, intro to, I have a limit video. Oh my god, why is this quality so low? Okay, it's higher. Oh, I lectured for like 30 minutes and then I stopped lecturing. Oh, that's so funny. Wait, wait, oh, I was trying to do series and sequences before my math class? I don't remember doing this. That's so funny. That's so funny. I thought I was gonna hate them so much. And then I was like, it's okay. I'm fine. I just have a really great professor. I really like him a lot. He like opened my eyes to like the world of not having bad explanations about things. Okay, a racing car travels on a circular track of radius. Okay, we're probably gonna do some linear stuff. 250 meters. The car moves with a constant linear speed. Find its angular speed. Okay, so V equals R omega. Geometric series is not that easy as it seems. Well, I mean, it's just like something to the n. That's all it is. You're just adding up a bunch of stuff. And then this gets you, if this value is less than 1, then that's convergent. That's all you got. That's all you got. Don't even have to worry. Oh, and you have to mix it with power series? Well, the kind of fun thing is that like, let me think. So if you have like this, right? 1 over 1 to the x, you know that this is x to the n. If your x becomes, let's say, x over 3, what you're doing is you're replacing this x minus 3, right? And what this is actually equal to is 1/3 to the n times x to the n. Or x to the n over 3n, which is kind of like a geometric series. I think power series in general, AR to the n. I think in general, power series are a little mystical, but the world is not always green. Yeah. Power series are a little mystical. You do have to kind of remember some things. Like if you don't know 1 over 1 minus x equals sigma x to the n, you're gonna have a bad time. If you don't remember how to do your integration tricks, or if you don't remember, like, if they're asking for tan inverse of x, and you don't remember your integration tricks, and you don't remember that the derivative of tan inverse is 1 over 1 plus x squared, you will have a bad time. But at the end of the day, you can always just find derivatives of stuff, right? Like, to know this formula, f to the n of a, x minus a to the n over n factorial. If you know that, then you're set, because you can always just plug in derivatives. It sucks, but like, it will work. The problem is you have to take integral, derivative, and limit with power series, which is insane. Yeah, I did ask my professor, because I was like, hey, so you mentioned that we use power series to like find solutions to differential equations. Like, what's up with that? Like, how often do you actually do that? And he was like, not that often, but sometimes. And I was like, okay. Okay, so for angular speed, okay, A, angular speed, V equals RW. So W equals V over R equals 45 over 250. I think that's right. The magnitude and direction of its acceleration. Ooh, interesting. Interesting. Yeah, I also think that... okay. I think that vectors are soft and warm, and they're sort of like clay. Like, they're not that complex. They're kind of like really important building blocks. Whereas series and sequences are like these really large, like pottery pieces that you need to understand really well and like carve into. You know? Like, I think that power series is such an accumulation of so many different things. In some ways, it's like, it is probably the blanket of like every skill you learn up until Calc 3, right? Like you're doing differentiation, you're doing integrals, you're doing, you know, trig stuff, you're doing like like all this stuff, right? And that's all in this one tiny package. And that tiny package is really hard to explain on top of that. The equilibrium of 3 tension ropes is pretty mental as well. Yeah, it's hard, like, for me, because I am a very visual person. I'm a very, like, I do very well with, like, connections to, like, physical things, which is why I talk about stuff so weird all the time. But that meant that, like, physics was kind of easier for me because when I learned it, my professor, you know, didn't have us, I didn't take my 2 years of physics in high school with calculus. I took it without calculus. And so we did a lot of stuff that was just about conceptually what existed, and like breaking down forces and getting really used to this other stuff. So I consider myself pretty lucky in the fact that I think that I have a pretty conceptual understanding of physics, and that's the part I think people struggle with the most. Yeah, when it makes it with more tedious stuff like center of mass and inertia, it can get really complicated. I mean, trying to like in physics, you'll have like a point A and a point B, and you can see both these points, but you also have like a point C and a point F and a point like Z and a point E, and you have to be able to go to like understand the path to take between all of these to get to here. And sometimes there's more than one way to get there, but a lot of the times there's one way that is the quickest or the most like intuitive, but like intuitive for physics. Is the sphere on the incline? Oh, like rolling friction? Yeah. We had something kind of similar. Actually, wait a second. Oh my god, I didn't even tell you guys about how my physics major went. There was this question we had. I don't think I told you guys about this. There's a question we had where it was like a cylinder, and there was a person like on the wall of a cylinder. And it was saying like, how fast do you need to rotate the cylinder to like keep the person from, there was no floor, to like keep the person from falling out of the cylinder. And I was doing my free body diagrams. I was like, okay, this is like static friction here. There's like, you know, mg here. There's like normal force here. And I was actually going insane about it for a little bit. And then I was like, because I was like, okay, maybe I'll just start writing out equations. Like, why do I have 3 directions of, you know, axes here? And I was like, okay, so, you know, a radial equals, you know, Fn, and it doesn't have any pushback, whatever. And I was like, okay, a tangent equals, and then I was like, wait a second, there's friction this way, not this way. It took me so long to figure out. I was like, what is happening? I was like, that's what it is. So then there's a delta y, and then that's fs minus mg, and then you get this equals mac, and yeah, you do that. Incline problem is tricky because it's hard to know if the force is positive or negative. Yeah, directionality in physics is definitely one of the biggest issues I feel like people don't talk about a lot. Well, not biggest issues. Like, I think it's one of the hardest things to get. Or to, yeah. I'll stick my guns on that. Let me get rid of this so he doesn't think I'm like taking the midterm. Oh, physics proofs are so silly. Physics proofs are so silly. Over 250. And this is meters per second over meters. So this will give, like, I guess just nothing. But yeah, V equals omega, R omega, so I'll just go with it. If it's wrong, it's wrong. 45 divided by 250. 0.18. This would be revolutions per second? I think. The range of my final is going to be a disaster because it'll cover 13 chapters. Oh my god, that's a lot. The magnitude and direction of the acceleration. Okay, so which way does it go? If it's a constant linear speed. AC. AC equals v squared over r. I was like, what? These questions have part A to E. Whoa, wait, 10 questions in 1 hour? Bro, what the fuck? My physics professor, he gives us a lot, but he gives us like kind of unlimited time. He makes us come in at 7 p.m. to take it though. Which is kind of silly. Okay, so 45 squared over 250 equals 45 squared by 250. 8.1. My math only gives me 1 hour, but it's 6 questions-ish. 8.1, and this would be in meters per second squared? Wait, radians per second squared? 8.1, and then direction. Direction is negative r hat. You're back. Hey, how's it going? Is this meters? That's not meters per second squared. What is that? It says this is meters per second. Meters per second squared. Wait, it is meters per second squared. What am I talking about? I feel like I'm... Oh, you're not... I think you give yourself not enough credit. Because you do a lot of, like... You've gotten a long way. For... Can I show you a game that will teach you group theory? Yes, of course. That sounds awesome. I'm almost done with this. What was I looking? Oh, yeah. Yeah. Okay, this is raid. Look up L game, choose player versus player, and fight yourself. 1 second. Okay, that'll be my reward. That'll be my reward. Okay, I'm almost done, I swear. We just need to go back and do anything without a box. Okay, those are all boxed. This one! Oh, I forgot about this one. Oh, I forgot about this one. Oh, ooh. Ooh. Ooh, ooh, ooh. Okay, okay, it's fine. What even was this question? I forgot. Oh. All right. Oh, yeah. Off. Woof. A tangential A equals centripetal A. I don't know if that's right. Wait, let me pull up my little capture again so you guys can see. Oh, I'm gonna need to crop it a little bit less. Yeah, it's kind of cutting off my work, but that's fine. I'll move it. This is not linear to angular. This is going to be kinetic. So the minimum value of v such that the pendulum bob will barely swing through a complete vertical circle. That means we have to say what? We need to know what velocity that the pendulum needs to go a full circle. Roller coaster problems are hardest? I like roller coaster problems. So what do I have here? What I wrote down was, okay, mv plus, okay, we have a momentum conservation. Mv plus 0, yeah, equals mv over 2, yeah, plus big mvf. Yes. So I can solve for some stuff. I don't think I need to do this. They're easy, the roller coaster. I think I need to just figure out what the velocity is to get it to go a full circle. I don't think I need... Gauss made a 2-page method? Gauss? I don't know. So I mean AC equals... We can't do that. I want to just know... Okay, so we have a length L. So we know that the distance, right, the delta x is going to be 2 pi r, so 2 pi L. And we want to know v equals what? To go, Gauss and Stokes theorems in vector calculus is pretty intensive. I have not, no, I know about like Gram-Schmidt and stuff, but not that. How do I want to start this? Have I learned gradient vectors? No, not yet. I think that's next quarter. Pretty sure. So that'll be in like week, month territory. Yeah, I think my classes start before I go on my long break. I'm not sure. They're difficult to learn. Well, I'm just cracked. I'm built different. I think I'll be fine. I'm pretty used to having people who don't really teach that much, so I just got lucky with my math professor this time. What do I want this velocity to do? Can I... Okay. This might be crazy. We want the UG at the top. I'm intelligent. Oh my gosh, you're so kind. You are also intelligent. I'm a little nerd is what I am. And I like thinking about things in certain ways. So what if, okay, UG at the top needs to equal MGH, right? No, you're not. Wait, I thought you were gonna say something funny, but that's just mean. Don't be mean to yourself. Okay, so UG equals, I think this is the way to do it. UG equals M, big M, G times 2L, which is gonna equal the kinetic energy, 1/2 M, right, so UG to KE, so equals 1/2 MVF squared. Yes! Franz Wolfgang enhanced Gauss method, but that's based on the uncertainty principle of 1 being 1/0, which cannot be present. Whoa, I don't know what that means. Well, I mean, I know what the words mean, I just don't know what you're referencing. So we have MG, we have 2MGL, that was 1/2 MVF squared. So get rid of the M's. So 4GL equals VF squared. Wait, does he want me to solve this? I think he wants me to solve this. What am I doing here? What am I doing here? It's 5th grade uni. Ooh. Are you European by any chance? A viewer. It's okay if it's too complicated. I haven't learned it. 5th grade, huh? They still call it that? Not in the EU? China. Oh. I am a first-year undergraduate. But in the Commonwealth. Huh. Fascinating. Is this a big M or a little m that I wrote here? This is a big M. Okay, so what is this V? VF equals... What am I trying to find? VV. Wait, what is the minimum? Okay. Alright, so equals VF. I don't need this. I don't trust that. Long live the king. I don't know what you're referencing. Linear algebra is fun, okay? Linear algebra is like really fun and really cute, actually. So V has to equal... This is a little m, this is a big M. Let's make it really small. Little m. It's nothing crazy. I don't have my streams from when I used to do linear algebra because that was before I had a model. That was when I was a silly little PNG. I heard it's not easy. Nah, it's easy. Literally the whole class, you're just writing numbers. If you can do like here, I'll give you a taste, okay? Here's a determinant. 1, 2, 3, 4, 5, 6, 0, 0, 1, 0, 0, 1. I'm not gonna put 0, 0, 1. 1, 2, 3, 4, 5, 6. 1, 2, 3. No, the 1, 1, 1. Okay, we do the determinant of this. Okay, 5 times 1 minus 6 times 1 minus I'm just doing it this way because my professor's been doing determinants this way. 4 times 1. Wait, 4 times 1 minus 6 times 1 plus 4 times 1 minus 5 times 1. Oh, wow, so hard. Can we listen to static while playing the L game? I'm not gonna put on static. Okay, actually, the last time I put on noise music, I did actually get copyright strikes for it. I'm gonna put on music if I play a game because I want it to be fun. Let me just finish this real quick. So V equals 8m GL over M. Let me see if that's any semblance of right. I mean, he didn't give any numbers, so I guess it would make sense that there should be no numbers in it. Uh-oh, did I miss a square root somewhere? Oh, I missed a square root somewhere. It will increase your learning if you do it right by 70%. No. No, don't make me put on static. That sounds not fun. That sounds not fun. Okay, so this is gonna be 4 square root of GL. 4M. Over little m? Yay! That's right. Awesome. Okay, we can do a little gaming. We can do a little gaming, if you will. Let me move. It's not I love how, again, I'm not a math major, guys. I don't need to know stuff. I'm just here for a good time. I'm here for a good time, and I'm here for learning a little math sometimes. I don't need to know group theory. I don't need to know jack shit. I only need to know linear algebra. Why is it doing that? Not Twitch. Why is it doing that? Oh my god. I hate not having a mouse. Where's my mouse? Okay, I'm gonna play this game. If this game takes like longer than I'm kidding, not 0 seconds. I'm not that impatient. Oh my god. I'm not gonna play it with static. That's not a good Twitch stream. It's not a good Twitch stream if I play it with static. I can't just be like, guys, I'm gonna play static. That's worse than like, it's not good. I mean, it's a funny. I don't know what you mean. I'm so confused. Okay, we're gonna try this thing. Okay, we're gonna try it. How do you have time to game when majoring in engineering? I don't actually. No, the answer is I could be gaming, but I actually do like clubs and stuff, so why was I about to put my mic away? I'm losing it a little. I do clubs and stuff, so that's why I haven't had time to game. Haven't had time to be a gamer. I actually didn't really game a lot before. I mean, I was just playing Minecraft for like a long time because I was being a nerd. Okay, let me look this up. What is this thing? Okay, the L game. Okay. And play to win? I don't know if I'm gonna win, okay? I'll try. No, wait, where is it? It's not showing up. You're doing aerospace engineering? No, I'm a mechanical engineer. That means that I want to like build doors or maybe build HVAC systems. Probably not HVAC. Play against myself? Okay. This is so... This is a simple strategy game. Okay. Place your L piece. Simply drag... What the heck? Okay. HVAC is boring. I mean, you're not wrong. It's kind of cool, though. I mean, it wouldn't be the end of the world. Now you can optionally move one of the black pieces. What is this game? What am I supposed to do? Mechanical engineer is a jack of all trades. Yeah. That's why I wanted to do it. I also kind of just wanted to work on oh, you want me to win? Okay. Oh. Wait, did I skip moving? God damn it, why did I skip moving? I could have... Computer science is having a downfall now? Can I leave it in the same place? I thought I saw it. Damn it. Okay, we're gonna... No, I skipped moving! Fuck! Oh, I have so many possible moves. Okay. I'm thinking. Did I do it? Oh. Oh, I forgot. You can overlap your old one. Majoring in CS now will not be wise. Honestly, here's the thing. So, like, I think I've talked about this before, but in the same way that I don't really super... How do I put this? Depending on what you want to do with CS, you might not want to major in CS. Because you can teach yourself, if you want to like work on coding, you can teach yourself a lot of code. Play with static? I'm not playing with static. I think I'm gonna copyright strike if I play static. These games really don't interest me either. This is like the worst parts of like my teacher used to make us do these brain teasers. She was like, oh, Damie, today we're doing brain teaser. Static does not have a copyright. I'm gonna play this game for maybe 2 more seconds. This is not a game, this is like a bad math problem. It's... How is this group theory? This is so lame. Static in Java? Do I remember what static is? It just means unchanging, right? It's like constant. It's like constant, but with a different scope or something. I am not like, okay. I think it's kind of funny because I am like very much a math guy, but I'm a math guy in a very like non-math guy way. Like the way I talk about everything is so, and the parts of math that I like are so, I don't know. They're not like this is not what excites me about math. Nor does it particularly... This is like game theory. Like 10 more minutes? 10 more minutes? Bro, it's like 8:30. I don't think I can beat this. Like, what if I... Comp sci is overrated? That's a lie. Comp sci is cool. You only have us two? I'm confused. I'm confused. I could be going to eat a cake right now. I could be doing so many things. I'm not gonna beat the... Just think about the game. Impossible. I'm sorry. Yeah, that's definitely what's happening right now. This really makes me remember, like, oh my god, the old bad math classes I had. Okay, cool. Oh, I'm having such a good time playing this game, guys. Oh, it's so awesome. It's icy? It's actually like, it was 65 out today. In what do they call it? The Central Coast. One 120 Celsius? Wait. Wait. No, not 120 Celsius. It's impossible. 120 Fahrenheit? Oh my god. That's hot. Jesus Christ. You live in a desert? Yeah, Death Valley? Here. I mean, yeah, I guess. I need to play Crush Crush. Okay, realistically though, I'm going to wrap up soon, and because I know my chat members love me promising streams and then not streaming, I think I might stream Wednesday. Let me check my calendar. I don't remember when I have time. Yeah, I could potentially do Wednesday. I don't know what I would do. I'd probably do math. You were at Central Valley once? Wow. Play more L game? I'm not gonna play the L game anymore. We're done with that. We're done with that. It was a really fun game. It was so fun. Thanks so much for the recommendation. I almost got robbed on a gas station on my way to Yosemite. Honestly, yeah. Oof. It's pretty bad. Okay, I will potentially be back Wednesday. If we do that, I will be doing 3D space stuff. I don't want to do more physics. I don't have more physics to do. Or maybe I'll do art. Or maybe I'll play Crush Crush. I probably won't play Crush Crush. I miss Crush Crush. Okay. Thank you guys for hanging out, even though it's like late. Normally I don't stream this late, but it's nice to know that you guys were hanging out. All right, I'll see you guys maybe Wednesday. Have a great night. My mouth tracking's not working because all my lights turned off, but like just imagine that I'm talking normally. Okay, see ya. Goodbye.